In this video, we will cover mutex lock and the semaphores that are available in the pthread and POS6 APIs. Now, these APIs are widely used for thread creation and synchronization by developers on Unix, Linux, and Mac OS. The mutex lock. Mutex locks represent the fundamental synchronization technique used with pthread. So to use a mutex lock, we need to include the pthread header file. A mutex lock is used to protect critical sections of code. That is, a thread acquires the lock before entering the critical section, and it releases the lock after exiting the critical section. Here, the pthread uses this data type for mutex lock. A mutex lock is created with this function. So we can create and initialize a mutex lock by calling this function. The first parameter is a pointer to the mutex. The second parameter is the mutex lock attribute. By passing none as a second parameter, we initialize the mutex to its default attributes. The mutex lock is acquired by calling this function, pthread mutex lock. Acquire the mutex lock. A mutex lock is released by calling pthread mutex unlock function. These mutex functions, they return a value of 0 if successful, and it returns a non-zero error code if an error occurs. This is a mutex lock. The semaphore, POS6 semaphores. Okay. There are two types of semaphores, named semaphore and unnamed semaphore. The POS6 specified two types of semaphores. These two types of semaphores, they differ in terms of how they are created and shared between processes. For the named semaphores can be used by unrelated processes, but unnamed semaphores cannot be used by unrelated processes. Named semaphore. Okay. Now the named semaphore, we need to, for the named semaphore, we need to use a named semaphore, we need to include the semaphore header file. And now we declare a semaphore. And then we use a semi-open this function to create and initialize the semaphore. The first parameter is a semaphore name. Here, when we're naming the semaphore SEM, the capitalized SEM. And then the oCreate, this flag indicates the semaphore will be created if this semaphore doesn't exist. And then the 666, this shows the semaphore has read and write access for other processes. 6 is 110. This means the read access, and this one means the write access. The 666 means this semaphore has read and write access for other processes. The last parameter is the initial value of the semaphore. Now the initial value is 1 in this example. Okay. After this semaphore is created, The other processes can access the semaphore by referring to the semaphore name, SEM. Now, the other process is called the semi-open, to open an existing semaphore. This function will return a descriptor to the existing semaphore. And then we have the semi-wait to acquire the semaphore. We have the semi-post to release a semaphore. Both Linux and Mac OS systems provide POSIX named semaphores. Unnamed semaphores. The unnamed semaphore is created and initialized using semi-initial function. There are first parameters. The first parameter is a pointer to a semaphore. The second parameter is a flag indicating the level of sharing. The third one is the initial value of the semaphore. Okay, here the 0, the second parameter 0, this means this semaphore can be shared only by thread belonging to the process that create this semaphore. And this 1 means the initial value of the semaphore is 1. This is a kind of binary semaphore. The unnamed semaphore use the same function, semi-wait and semi-post, to acquire the semaphore and release the semaphore. Okay. All these semaphore functions return 0 when successful and return non-zero when an error condition occurs. Okay, this is all about the process synchronization. This video will stop here.